Alright, welcome back to our series on percent yield. This is percent yield part 2. So in the first percent yield videos that we did, we were looking at problems that wanted you to find a percent yield. So in other words, you took the percent yield equation, percent yield equals actual over theoretical times 100, and you actually used that formula to try and get an answer for percent yield. These problems are going to give you the percent. So in these problems, they're going to tell you like 86%. So when you work the problem, you're going to get a balanced equation, and it's going to tell you that the yield is, let's say that the yield is 60% in the problem. So it's going to tell you the yield. Now, reality of it is, if I wasn't interested in teaching you anything, I could teach you how to do these problems where you can get the answer and you don't even have to think about it. But I want you to at least understand something, because reality of it is these problems are almost as easy as if you jump to the right in a problem, they're pretty much as easy as you times by the percent, or like in this case 0.60 if it's 60%. If you work a problem and it involves you jumping to the left in the problem, you're going to divide by 0.60. Now, if that's as far as you're interested, then guess you can pretty much quit watching this video. Make sure you give it a good rating. Thank you, everybody, for watching. Because that will literally, this is enough information to get you to a percent yield. Do your jump. If you jump to the right, do your jump, times by 0.6, you'll have the answer. If you catch yourself jumping from a product to a reactant, so products, reactants, things you should know by now. Oh, wow, I just totally goofed that up. Reactant, things I don't even know. Jeez. You should get a new video. I heard that guy on Khan Academy is pretty awesome. Product. So there you go. So, anyway, we got our start. It's that easy. Now, we're going to try and step it up a notch. Let's do a real problem, and let's see if we can actually understand why we're doing it this way. Now, I'm actually in my notes, I'm going out of order. Number 5, apparently I was insane. CH3, COOH. I wrote it out of the organic style, and I guess it was a cruel joke, only not to think the joke was on me. But I'm going to go ahead and do number 6 out of my notes first, and I'll leave that there for a second. You can pause it if anybody's trying to look at it on there. But anyway, I'm going to go to number 6, and here's the equation for number 6. It tells us that oxygen gas is reacted with nitrogen monoxide to make nitrogen dioxide. Now remember, before we even start this problem, we have to have a balanced equation. So you can quickly look, 2 and 1, 3, we're not balanced, but I can balance this one pretty easy. I'm going to slide a 1/2 in front of that O2, and now we got balanced equations. Now I know some teachers will frown upon that 1/2. If anybody takes like a Blackboard online class, it won't let you do that half, so you'll have to go 1, 2, 2. But anyway, we can do this. This problem says that 5.7 grams of oxygen reacts with excess. Oh my goodness, ain't this the sweetest problem you ever saw? Look at this. It tells us that NO is the excess, which means this is the LR, and it says that you've got 5.74 grams of that O2. So it's giving you the mass. It's told you this one's excess. It's just like I've always told you. You give me one number, I can tell you anything else. I can give you how many grams of NO we need. I can tell you how many grams of NO2 we make. Well, that's what this problem wants to know. This problem wants you to find how many grams of NO2 you'll make. But there's one catch. When you go to read this question, this is the catch. This 80.2% in the question. So I'm going to write that right down underneath here. 80.2%. That's very important. And all it means is this. When we make our jump in this problem, when you jump, you're only going to get 80% of whatever you try to make. And that's literally how easy these problems are. So we can start this problem off. 5.74 grams of O2 And let's now jump to NO2. Let's do a molar relationship. Well, first, before we can jump, we have to be in moles. So O2 would be 16 times 2. 32 grams of O2 for every 1 mole of O2. Put our X, draw our line. We're ready to jump. Your relationship, and I know we haven't done this before, but that's okay. For every 1/2 mole of O2, we'll make 1 mole of NO2. Put our X, draw our line. All right, next step. We're in moles. We need to get the grams. 1 mole of NO2 has a mass of, well, you can help me out here. 16 times 2 is 32. And 14, there you go, 646. So there's 46 grams of NO2 per 1 mole. Now we're ready to plug this in the calculator. Let's pull out a nice old Casio here. So get that out. On sesame. And so it looks like I've got 5.74 times 46 divided by, what we got here, 32 times a half, which was 16. Oh well, too late. So this is 16.5 grams of NO2. Now, I want you to take note of something. That's 16.5 grams of NO2. Notice how I've not put a box around this yet. And this is the reason why. This is telling me that I'm supposed to make 16.5 grams of NO2. That's saying that what is this? This is in theory, I should make 16.5 grams. Reality of it is, I'm only going to get 80% of whatever I try and make, which means I got one more step in this problem. 16.5 grams times 80%, 80.2 in this case, which means in this problem, 16.5 times 0.802 equals I messed up, so let's try this again. 16.5 times 0.802 equals, this is 13.2 grams of NO2. Put my box around that. So this first number I got, this was my theoretical yield. This is my actual yield down here. So I may think I can make 16 grams, but I'm only going to make 13 grams of biscuits. I'm sorry. I think I'm hungry. But anyway, this is all we're going to be doing. All right, now let's try and do a problem. And unfortunately, this is the one I went crazy with and made a huge, gigantic problem out of it. Kind of wish I'd done something different in here. Trying to think of something else off the top of my head, but I don't got it. So I'm going to go into this one. This thing is a beast. CH3OOH plus C2H5OH CH3. Man, I'm getting wore out just looking at this thing. Anyway, I'm going to do it because it's a real-life manufacturing process we got here. It's the production of ethyl acetate. And to make ethyl acetate, we need two things. We need basically vinegar, acetic acid, and ethanol. You don't know what ethanol is? Basically, moonshine. So anyway, white lightning. Anyway, so here we go. I'm going to start off by writing the equation. And again, I'm already regretting this, and you'll see why. Here's the equation on this one. CH3 COOH, oh my goodness, plus C2H5OH yields CH3COO C2H5 plus water. What's funny, the water is the most beautiful part of the equation, and we're not even jumping to the water at any point. And just like always, we need one number. And when you read the problem says you want to make 62.5 kilograms of this. So here's our one number. So we want to try and make, I'm going to write it up here. Now it's in kilograms. Before we do our stoichiometry, let's write 62,500 grams. So in it asks question mark on the vinegar. So right off the bat, this looks like a very easy problem, and it is an easy problem. It's just a one jump problem. And let's not even worry about the percentage. It says that the percentage is 69.1%. So there's our percent in this problem so far. Nothing looks too crazy in it. All right. So now let's work the problem. We're going to start with, and I hope you're ready for this, 62,500 grams CH3COOC2H5. Draw a huge line, put an X, draw a line. I'm not going to even try fitting this in one line, so I'm going to split it up here a little bit. So times, and now we've got to figure out how many grams CH3COOOC2H5 weighs. I'm going to grab a calculator. We got 4 C's in that thing, so that's 48 plus, there's 5 H's, or 8 H's, so plus 8, plus we got 2 O's, so that's 32, so that's 88. So there's 88 grams of CH3COOC2H5 for every 1 mole. I know you're hating me already, ain't you? CH3COOC2H5. It's hard to complain, though. I'm sitting here doing it with you. Draw another long line. So we're ready to jump. I mean, other than the weird numbers and the weird equations, this is nothing different. The only new part in this problem is what are we going to do to 69.1 up here? Next step, it's 1 mole to 1 mole. So for every 1 mole, CH3COOC2H5, we will need 1 mole of this reactant, CH3COOH. And we're not done. That's got us to moles. I need one more step. I need you to convert this to grams. So times for every 1 mole of CH3COOH. And if you're wondering why it's written this way, in organic chemistry, this tells me, this COOH, it tells me it's a functional group. It tells me it's an acid. And so that's the purpose of that. I know you haven't had any organic yet, but you will. Now, to figure out how much CH3COOH weighs, well, let's see. We got 2 C's, so that's 24. What else have we got? We got plus 4 H's and plus 2 O's. So that's 60 grams of CH3COOH for every mole. So we're finally done with this. And let's see if I can plot this in the calculator. 62,500 times 60 divided by 88. And so that answer, and excuse these interruptions, they kind of happen all the time. There's no softball practice today. That's no softball practice. So please do not come to softball practice. I'll find you if you show up. Okay, now we're back in the game. So this is 42,613 grams of CH3COOH is what is in this. Now, here's the thing. Just like the last problem, this is not the answer. If we actually start with 42,000, in other words, if this is what we start with, we will never get to 62,500. This is what we want, is 62,500. Because here's the thing, we're only going to get 69% of what we try to make. So if you start with this and try and mix up your little concoction and get your ethyl acetate, you're never going to get it. You're going to get you're going to get 69% of this number. Y'all, it's a very easy thing to compensate for. I need to use more of this in this problem. So all I'm going to do is take this number, and all I got to do is divide by 0.691. And so I'll take it in my calculator, divided by 0.691 equals 61,600, well, basically, and 70 grams CH3COOH. That's why I put my box around there as my answer to this one. And that is all she wrote to getting this problem done. Alright, so at this point, good luck. I left a little help with the last problems on your assignment, so a little cheat sheet guide basically to try and help you out with those, and maybe it will work. And again, I hope you understand what's going on like with this one. We need to overestimate. It'd be like making biscuits. And whenever I make biscuits, so let's say, here's my flour, and I'm going to try and jump to biscuits. I love some biscuits. The problem is, I may want to try and make 8 biscuits. In theory, I should start with 2 cups of flour to make 8 biscuits. The only thing is, if you ever saw me make biscuits, I probably wear at least 1 cup of flour. So that means when I do biscuits, I only get a 66% yield. So all you got to do is think backwards. If I want that 8 biscuits, I can't start with 2 cups of flour because I'll lose most of it. So what I need to do, start with 3 cups of flour, and when I lose 1/3 of it, I will still get the 8 biscuits that I wanted on the other side. You know what? The more I thought about it, I'm going to go get some biscuits. Everybody, y'all have a good day.